Okay, let's look at this first one. So it says a brake master cylinder piston has an area of 1 centimeter squared. The piston in the brakes has an area of 5 centimeters squared. So our second area of the bigger cylinder is 5 centimeters squared. So the master cylinder is pushed with a force of 600 newtons. So the person presses on this with the brake pedal in the car with this force. And what we can do is calculate the pressure on the first one, so the master cylinder. So we do P equals F divided by A, which is 600 divided by 1, which is equal to 600 newtons per centimeter squared. What is the pressure on the second brake? Well, it's exactly the same because P2 will be the same as pressure 1, so it is 600 newtons per centimeter squared. Calculate the force applied. So now looking at the second side, we can do P equals F over A. Pressure 600, just like on the first one. We're trying to find this force, but the area on the second cylinder is 5 centimeters squared. Don't need the unit in there. Multiply both sides by 5. And it gives us that the force on the second one on the brakes will be 3,000 newtons. So it allows you to press with your foot with a force of 600 newtons, which is quite big, but create an even bigger force on the brakes of 3,000 newtons. Part D, explain why water is not used in car braking systems. One reason is it tends to absorb little bubbles of air which are compressible, which can make your brakes a little spongy, that they compress and don't apply that force. But the main reason is on a cold day, water could freeze, and it actually expands as it freezes. So what would happen is the brakes would just constantly be on, which wouldn't be very good. Question 49 then says hydraulic press has pistons with an area of 5 centimeters squared and 600 centimeters squared. What force is needed on the smaller piston to create a pressure or to support a force on the second one of 7,200 newtons? So you can actually see this is for the diagram above that question. It looks like it goes with the previous question, but it doesn't. So what we can do there is we can work with this side first, because we've got the force and the area for that. So we do 72,000 divided by our 600, and I guess that's 12 newtons per centimeter squared. But that's also applied to this side too. So looking at the left hand side, we do P equals F over A, but P's 12, just like the other side. We're trying to find F, and we know A is 5. 12 times 5 equals F. So F is equal to 60 newtons, okay? So if we apply a force down here of 60 newtons, that will be able to support a force of 7,200 newtons on the other side. So this is another example of force multipliers that you would have come across in year 10.